The introduction for this project is the IoT-based smart agriculture monitoring system leverage Internet of Things IoT technology to monitor and optimize farming conditions. By integrating sensors, microcontroller, cloud computing, and data analytics, the system helps farmers to make data-driven decisions, improving efficiency and crop yield. The problem statement for this project is agricultural productivity is influenced by environmental factors like soil moisture, temperature, and humidity. Traditional farming methods often lead to inefficiencies due to manual monitoring and human error. An IT-based smart agriculture monitoring system offers real-time insight for optimizing resources and improve crop yields. Climate change increases the demand for accurate monitoring for sustainable practices. Farmers struggle to analyze environmental data effectively without a centralized system, making decision-making difficult. A cloud-based dashboard can help visualize data, enhancing decision-making and productivity. There are three main objectives for this project. The first one is to design and implement an IoT-based smart agriculture monitoring system to optimize resource usage by providing real-time data on soil moisture, temperature, and humidity. This will reduce water waste, minimize fertilizer runoff, and promote efficient energy consumption. The second one is to develop a cloud-based dashboard to centralize and visualize environment data. The last one is to utilize the real-time insight from the monitoring system to adapt farming practices to changing environmental conditions.
Project scope. These are the four main components that we're going to use for our project. The first main component is microcontroller ESP32. Microcontroller ESP32 will act as the processing unit collecting sensor data and sending it to the cloud for analyzing using wireless communication. It will read the data from the sensor at a regular intervals, 30 minutes. For the HT11, the HT11 measures temperature and humidity simultaneously. It collects real-time data to track conditions affecting crop growth by placing it above the ground to monitor surrounding air conditions. The output from this also will be sent to the microcontroller. The third main component is soil moisture sensor. Soil moisture sensor measures the water content in the soil. The sensor will place at the root level of the crops and provide output to the microcontroller. Blink. Blink is a cloud platform used for remote data visualization and control via a mobile app or web interface. It processes and visualizes sensor data from the microcontroller and provide farmer real-time visual of graphs and charts. So that's all for our project scope. Next is project significance. First, for our project, it improves water efficiency. By using a soil moisture sensor, the system ensures plants receive adequate water, reducing waste and improving yield. For example, if the soil moisture drops below a certain level, the system can automatically activate a water pump to irrigate the crops. Once the moisture reaches an optimal level, the pump turns off, preventing water wastage. This will prevent from overwatering, which can cause root rot and nutrition leaching. Next, cost-effective and scalable. The system is affordable and can be expanded with additional sensors for other agriculture needs. For example, a small farm can start with basic sensors such as soil moisture, temperature, and humidity. As the farm expands, additional sensors like pH sensor or a light sensor can be integrated without replacing the entire system. This will lead to smart farming technology accessible to small and medium-sized farms. Next, prevention of crop damage. Prevention of crop damage means detects unfavorable conditions early, reducing water wastage and preventing soil degradation. For example, if the temperature becomes too high or the soil moisture drops too low, the system can send a notification to the farmer's phone via the Blink app. In severe cases, it can automatically start irrigation or activate a cooling system, such as misting fans or greenhouse farming. With our project, it can protect crops from drought extreme heat or overwatering, reducing crop failure. It also helps to prevent soil degradation by ensuring proper moisture balance. Other than that, it can reduce financial loss that due to damage or lost crops. Next, scalability and customization. The system can be adapted for different farming needs, making it a long-term solution that grows with technology advancement. For example, a vegetable farm may require soil moisture monitoring, while a hydroponic farm may need pH and nutrition level sensors. A large farm can integrate weather predictions, application programming interface for advanced climate monitoring. If pest control is an issue, automated pesticide sprayers can be added and triggered by insect detection sensor. This can help for farmers can customize their system to match their crops, climate, and soil conditions. It ensures long-term usability since it can evolve with changing agricultural demands. Next, reduce human effort and increases efficiency. Automation reduces the need for excessive manual labor, making farming more manageable and sustainable over time. For example, instead of checking soil moisture level multiple times a day, the farmer can monitor everything remotely via a smartphone. If needed, this system can automatically water the plants, eliminating the needs for manual irrigation. This allows farmers to save time and focus on other important tasks like harvesting or crop planning, especially beneficial for large farms where manual monitoring would be time-consuming. Lastly, data logging and analysis. For example, if the farmer noticed that the soil moisture drops significantly every afternoon, they can adjust irrigation schedule to water the crops before dehydration occurs. If temperature and humidity fluctuation affect certain crops, the farmer can take preventive measures like using shade nets or misting system. This will help to improve decision making for better crop planning and resource management, and also farmers can predict potential risks and adjust strategies to maximize yield.
At the heart of our system is the ESP32 microcontroller, working alongside the DHT11 sensor to measure temperature and humidity. The soil monitoring sensor ensures farmers get real-time soil moisture data. All this information is sent to the Blink app for easy access. Farmers can monitor their soil conditions anytime, anywhere using the Blink app. This real-time data allows for smarter decisions, like when to water crops or adjust farming practices for better yields. By optimizing water usage and improving efficiency, this project contributes to sustainable agriculture. Future developments could include AI-powered predictive analytics, making farming even smarter. In summary, with technology, we can revolutionize farming, reducing waste, increasing productivity, and securing our food future. The journey to smart agriculture starts today. Thank you for watching.